Assistant Professor. Myself, Pujas Patel, Project Manager for XYZ Corporation. About our team and roles: Project Manager, coordinate deliverables and documentation, business analysis, create project documentation and define analysis requirements. Abdul Hujit, Data Engineer, integrated cloud solution and automated processes. Abin Devasya and Nizamuddin Naisar, data analysis acquired, cleaning and analyzed data. Disha Patel and Karan Bojak. Introduction. Pro- Project objective: demonstrate analytical and data processing capability to XYZ Corporation. Data overview: dataset, online retail transactional data. This is the link of the dataset. Time frame: 1/12/2010 to 9/12/2011 is almost 1 year of data. Size is more than 500,000 of record with 8 variables. Subject area: business transaction and for XYZ online company. Next, data engineering. The upcoming slides will be explained by the data engineer. Thank you.
Hello everyone, my name is Abin Devasya and I'll be presenting the data engineering portion of our project alongside Nisam. As a team, we worked together to ensure that the data pipeline was reliable and efficient. This included acquiring the dataset, cleaning and pre-processing it to address any inconsistencies, and securely storing it for further analysis. Building a good data pipeline was critical because clean, structured, and data forms the foundation for accurate and meaningful analysis. Without it, insights could be skewed or unreliable. Our first step was sourcing a dataset suitable for the project. Many of our responsibilities included the data acquisition. We sourced the dataset from the UCA machine learning repository, which is well known for its reliable datasets. Our dataset contained of over 500,000 transactional records, which included columns like invoice number, stock code, customer ID, and unit price. Once acquired, we cleaned and pre-processed the data to ensure its quality. For example, we handled many of the missing uh, entries in the columns. And for storage, we selected MongoDB Atlas, which is a cloud-based NoSQL database. And the tools used in our projects include Python, which was the core programming language used throughout the process. The key libraries that we used include Pandas, NumPy, and PyMongo. Pandas was used for manipulation and cleaning, NumPy for handling missing values and numerical computations, PyMongo for database operations with MongoDB. Mongo, we also use MongoDB Atlas, which served as a cloud-based NoSQL database. Then we used Jupyter Notebook, which provided an interactive environment where we could write, test, and document Python script. It also allowed us to keep track of our progress and debug any issues effectively. Next step was dataset acquisition and pre-processing. Data acquisition was the first major step. We wrote Python script to fetch the dataset directly from the UCI repository. The dataset included 500,000 records, and after acquiring the data, we previewed its structure to identify any inconsistencies or missing values. One of the challenges we encountered was handling null values because there were like a lot of null values. Uh, for instance, many entries in the customer ID column were blank. We resolved this by replacing them with um, guessed instead of the null value. Similarly, missing product descriptions were filled with unknown. These steps ensure that the dataset remained comprehensive and usable for the analysis. Um, Following the data acquisition, we focused on validating and transforming the data types. Columns like quantity and unit price were converted to integer and float types, respectively. This was crucial for ensuring accurate calculations such as monthly sales trends and revenue analysis. Additionally, we checked for and removed duplicate records to maintain the dataset's integrity. Once all the issues were addressed, we structured the clean data into Pandas data frame. This format not only made the dataset to work with the Python but also prepared it for secure storage in the MongoDB database. Over to Nisam. Thank you.
Thank you, Abin, for setting the stage and explaining the initial aspects of data engineering. I will now continue with the data engineering portion, how we pre-processed, engineered, and managed the data to ensure it was ready for analysis. To enrich the dataset, we implemented feature engineering. This involved creating new variables that added values to our analysis. For example, we extracted the month from the invoice date column to analyze monthly sales trends. We also identified the top 10 products by total quantity sold, which provided insights into customer preferences. This analysis highlighted which products were performing well and which ones required additional marketing or adjustments. By grouping and summing sales data by month, we calculated monthly sales trends, and this analysis revealed peaks in March and November, aligning with promotional campaigns and holidays shopping trends. After preprocessing and feature engineering, we stored the cleaned and transformed data in MongoDB Atlas. Using Python's PyMongo library, we connected to the database and also created a collection named sales data within a database called retail database. The Pandas data frame was converted into dictionary records for seamless insertion into MongoDB. To ensure the data integrity, we ran queries to verify the record count and check for any issues. Retrieving data was equally important, so we also wrote scripts to pull the stored data back into Pandas for further analysis. During this process, we excluded irrelevant columns to focus on the most critical aspects of the datasets. These retrieval and validation steps ensured the data was ready for advanced analytics and visualization. Here is an overview of the database structure. The clean data was stored in MongoDB Atlas, a cloud-based NoSQL database that offered the scalability and flexibility we needed. Each record in the sales data collection represented a transactional entry, complete with customer and product details, quantities, and timestamps. This structured storage approach allowed us to efficiently query and retrieve the data for insights. The preprocessing and feature engineering steps led to several key insights. The first one is most sold products. By analyzing total quantities, we identified the top selling items. This information is crucial for inventory management and marketing strategies. The second one is countries with highest sales, geographical analysis revealed the countries contributing most to sales, highlighting potential markets for expansion. The last one is monthly sales trends. That one is the sales trends showed seasonal peaks, particularly in March and November months, which are correlated with promotional events and holiday seasons. These insights prepared the data for advanced visualization, allowing us to showcase actionable trends. And this concludes the data engineering section, where we transformed raw data into a structured and actionable format. With the data now prepared, I will hand it over to Disha Patel, who will walk us through the analysis and insights derived from this data set. Thank you.
Hello everyone. So for this project, I, Disha Patel and Karan Bojak, we both are data analysts. So our responsibilities are to use Python libraries like Pandas and NumPy for the analyze trends and patterns. Also, we need to perform groups, aggregation, and descriptive statistic to extract meaningful insight. We also have to develop the visualization and highlights the key insights and actionable outcomes for the corporation. We also summarize the findings and ensure the insights are concise, clear, and aligned. We also have to collaborate with our developers, business analyst, and project manager to ensure the smooth integration of data analysis into the broader project. We also have to provide feedback to inform the development of future enhancement like web-based dashboards. Here we have the business questions and the analysis objective. So our main business question are, the first one is what spending patterns exist across different customer segments. The second is which products are the best performers in terms of sales and who are the top customers by total spending. Analysis objective is to leverage data to uncover insights that drive business decisions, including customer segmentation, product marketing strategies, and optimization of resources for greater sales impact. Moving forward to the first chart, our first visualization is monthly sales performance analysis. So the line chart shows us the monthly sales trend. The key insights are, the chart highlights a consistent increase in sales from January to June, followed by a plateau in the second half of the year. Seasonal spikes in March and November align with promotional campaigns and holiday shopping trends. So, implications are maintain and enhance promotional efforts during peak months to capitalize on seasonal demand and explore strategies to sustain sales momentum in off-peak month. Our second visualization is geographic sales distribution. So the heat map showing sales distribution across different regions. The key insights are that the heat map reveals the highest sales concentration in urban areas while lower sales in certain regions. Certain regions shows untapped potential with moderate sales but a growing customer base. So the implications are increased focus on urban region with tailored marketing strategies, as well develop outreach program to penetrate rural markets and expand reach. Our third visual shows top selling products. So the visualization bar charts shows the top 10 best selling products. The key insights from the visual is that Postage is the clear leader, accounting almost 25% of total sales, followed by the Kingston and the Papercraft as well, Little Birdie with 80% and 50% respectively. Products with low performance indicate either insufficient demand or marketing gaps. So the implication could be allocate more resources to promote high performing products and investigate reasons for poor performance of lower ranked products and address the challenges. Our last visual is analyzing the customer base. So the bar chart of shows the top 10 customers by the total spending. The key insights are following. Customer number 14646 leads with 60% of the total revenue, followed by 18102, which is 14%, and the 1745 is 11% of revenue. The top 3 customers collectively contribute over 40% of total revenue. A significant drop in spending is observed beyond the top 5 customers. So the implications are prioritize loyalty programs for the top spenders to sustain the revenue, and also analyze spending patterns to lower rank customers to encourage them for higher engagements.
Hello, my name is Karan Bojak. I am also data analysis of this project. So today I am going to present challenges and learnings. First, data quality issue, inconsistent or missing data, making it challenging to obtain accurate insight and affecting the overall reliability of the analysis. Data integration, difficulty in integration data from multiple sources, leading to complexity issue and potential mismatch in key variable. Third, uneven spending distribution, large disparity in customer spending, making it challenging to identify patterns across all customers and quick analysis towards top spenders. Identify meaningful trends, difficulty in identifying significant trends from a wide variety of data points, especially when customer behavior are diverse and complex. Fifth, data scalability, handling to large dataset efficiently, especially when scaling analysis for a global customer base with varying data structure. Summary of analysis. Customer insights. The analysis revealed key spending pattern highlighting top spender and customer segment with the highest revenue potential. The top 10 customers accounted for a significant portion of total spending, with a few high value customers dominating the market. Product performance. Best selling products were identified with certain product, example product X driving a large percentage of total sales, while others show weak performance, suggestion possible demand or marketing issue. Trends and patterns. Spending trends varied significantly across customers with a clear divide between high and low spender. Segmenting this group helped uncover actionable insight. Thank you.